Okay, so our first example is actually a sine function, and that means I will have symmetry with respect to theta is equal to pi over 2, basically our y-axis. So what I'm going to do is I'm going to highlight this right now, so it's going to help me when I'm graphing later. So I have this right here, and we will be using our calculator to check, but you have to show all of these calculations by hand. Okay, so the first thing that we want to look at is how many petals we have. The number of petals, remember, is based on what? It's based on the coefficient, right? So here, this is an even number, so that means this is going to be 4. The length of the petal is the coefficient of your trig function. So in this case, it's a coincidence that these are both 4. Okay, but this is n and this is a. The distance between the petal points is going to be 2 pi divided by the number of petals, which is n. So in this case, it's 4. So I'm going to need this common denominator, but I would then just say pi over 2. Okay, so it's based on the number of petals. And then we'll talk about a petal point in just a minute. So as we talked about before, in order to get our values here that we're going to use to get our theta as well as our r value, we want to use values from the unit circle that give us easy values to plot, meaning we don't want anything with a radical. We want something with either a fraction or a whole number. So we want 6 points, okay, and we're going to use the values from here to here. Okay, so instead of 3 pi over 2, we're going to use negative pi over 2 to pi over 2. So I am plotting actually 2 theta, I'm picking 2 theta, and then I will plot theta. So here I have 2 theta, and I'm going to pick the values when I plug in for sine that are going to give me whole numbers. So the values that I'm going to choose are going to be negative pi over 2, because remember, when you take the sine essentially of 3 pi over 2, you get negative 1. It's the same thing as negative pi over 2. And then from here, we're actually going to pick negative pi over 6. I'm not picking pi over 3 because that gives me the square root of 3 over 2, square root of 2 over 2. I don't want any radicals. This is actually negative 1/2. So it helps me. Then we'll pick 0, then pi over 6, which is in the first quadrant, and pi over 2. So then that way, whatever points I get over here, because there's symmetry with respect to theta is equal to pi over 2, I can then transfer them into onto this side. So r is equal to 4 sine of 2 theta. Okay, and what I'm going to do is plug in the values. So I have 4 sine of negative pi over 2. So I'm trying to find out what this value is, and actually we talked about it already. This is negative 1, so this is 4 times negative 1, so then this is negative 4. So my r value is negative 4. So then I pick negative pi over 6, which is actually right here. Okay, so I have 4 sine of negative pi over 6, which is equal to 4 times negative 1/2, which is negative 2. Then we said we were going to pick 0, pi over 6, and then pi over 2. Okay, so let's plug in 0. 4 sine of 0 is equal to 4 times 0, which is 0. And then 4 sine of pi over 6, which is 4 times 1/2, positive 1/2 because we're up here. So this is 2. And then 4 sine of pi over 2, which is 4 times 1, or 4. Okay, so remember, a petal point is actually a value or a trig value that has the exact petal length. So I have it here, but I need my theta. So now I have to figure out what my theta is. So remember, these values right here gave me, these trig values gave me nice values to plug in to the trig function. Now I actually need the angle, which is based off of 2 theta. So if I said 2 theta is equal to negative pi over 2, if I wanted to solve for theta, I'm either going to divide by 2 or multiply by 1/2, which makes this negative pi over 4. I do the same thing here. Okay, so this gives me negative pi over 12. Here, this is just 0. This is pi over 12, and this is pi over 4. Okay, so what that means is the points that I'm going to plot on this graph are here, 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 and all of these that are in orange. Okay? Now, when I'm asked for one petal point, this has the length. This is not the length. Negative is not the length. Positive 4. So this is my petal point. So I put pi over 4 here. Okay, so we had to wait until we made the chart so we could determine that's an R. Okay? All right, so let's plot our points on the graph, and then we'll do this last part using the calculator. So what we want to do is start plotting. So I have theta, which is negative pi over 4. So negative pi over 4 is actually, if this is positive pi over 4, negative pi over 4 is where? Here. Okay? So if it's 7 pi over 4, negative 4, that means when I plot this point, it's actually going to go in the opposite direction. So it's going to be on this line here. So I need to go 1, 2, 3, 4 and plot that point. Okay, so this is plotted right here. Then I have negative pi over 12. So if this is negative pi over 6, then pi over 12 is going to be half that distance. So it's going to be in between here, and it needs to go negative 2 units. So basically it's either right here, just showing you the dotted line, which is basically going to end up in this direction because this is negative 2. So I need to go negative 1, negative 2 like this. And this is actually going to be the width here. Okay, so then 0, 0, I plot my point here. And then I have pi over 12, which is now here, and positive 2, which is here. Okay, and then pi over 4, 4. Pi over 4, 1, 2, 3, 4. Oops. Okay, so what we have is a width. So if this is my petal point, I don't have a whole lot of points here, so I need to take a look at what are my petal points. So your petal points here, if you're first, if I start with pi over 4 because that's at the highest, okay, then I'm going to add 2 pi over 4, which means I'm going to have a point at 3 pi over 4, which I already have one. Okay, and then I add another 2 pi over 4, which is 5 pi over 4. I don't have a point out there yet, so I'm going to go over here, and at 5 pi over 4 I'll have 1, 2, 3, 4, and I'm going to plot this point out here. So that means I have a width right here, and I also have a width right here, which is essentially my pi over 12 units, like this. So that means I would have one here also. Okay, and then the last one when I add is 7 pi over 4, because you're adding, okay, the distance. So that means I need to go over here, and I'll go 4 units out. 1, 2, 3, 4, and plot. So that means if this was the pi over 12 at 2 and 2, that means I should also have one here. And now I can sketch my graph. Okay, so I'm going to go like this. Technically, you wouldn't really lift up your pen or your pencil, but I can't see. Okay, so not perfect, but looks pretty good. I have 4 petals. They're equidistant apart. So first of all, what I want to do is go into my calculator and double check that I did okay. So let me clear out the function that I had in here before, and I'll type in what I have. So my function is 4 sine of 2 theta, and I will graph that. Boom, 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 boom. Looks very similar. Okay, so now what they want us to do is highlight, so I'll just use green, highlight on the graph the restricted domain from 0 to pi. So I already put the function in here, so now I want to go in here and I want my minimum to be 0, but this is currently 2 pi. I'm going to change this to pi. So now I'm going to graph it, and it's only in the first and fourth quadrant, so now I just want to highlight this. Why? Because the directions told me to. Okay, so that's the restricted domain, and you'll do this with your calculator. Okay, so that's the first one.